Greetings everyone and welcome back to the bench. Today we're going to talk about making coils for the JAT 501 amplifier project, and it could apply to really anywhere you need a coil. Those tend to scare people away because they can solder in the other components, but when it comes to coils and how do you make them look nice, how you get the right values, well, the value is not super critical here, but you have to know how to wind it and to get it in the ballpark anyway, and you want it to look nice. So I'll talk about how to select your coil and how to wind a nice one. Well, in the output stage of the JAT 501, in series with the output we have a parallel resistor and inductor, and the purpose of those components are to reduce the effects of a pure capacitive load on the output of the amplifier. Amplifiers do not like to drive capacitive loads, and normally a loudspeaker would not be a capacitive load, or I should say a pure capacitive load, but long speaker lead runs pose more of a capacitive load, so we want to reduce that effect, especially at high frequencies. So we have the inductor in the circuit, and to lower the Q, because if you have an inductor and capacitance, you have what's known as a resonant circuit, and you want to lower what's called the peak of that, or the Q, and that's what the resistor does. And by the way, ignore these here in the actual circuit. This was for simulating in LT Spice. I was running some simulations to see how it would perform, so I had some inductance and load here. So yeah, this here is not part of the output. This and this are. Normally an amplifier shouldn't require too much inductance, probably around 1/2 to 1 microhenry, maybe a little more. And I'm shooting for somewhere around 1 microhenry. You can certainly run the JAT 501 with a little less, but I would stay above 1/2 microhenry. Okay, so now I'm just testing my coil. I'm kind of curious of what the value actually is. So using my old Radio Shack data book is the resonance formula. I'm going to set up a tank circuit because I can set the frequency, I know the capacitance, which will allow me to calculate the inductance. So I can use this resonant formula here from my Radio Shack data book from 1972, 50 years ago. Wow. Back then I lived in Kokomo, Indiana, riding my big wheel on the sidewalk. Any listeners out there from Kokomo, Indiana? Well, since I want to solve for inductance, I need to rearrange this equation. So what I have to do is divide frequency. I guess I should explain these. Frequency 2 pi square root of inductance and capacitance. So to rearrange this, I need to divide off the frequency on this side, and also have to divide it off on this side so it's in the denominator. So now it's 2 pi f. Well, we have this pesky square root in the denominator, and I got inductance I need to get over on this side. So I multiply by the square root of L on both sides. So that gets it out of here and leaves us with the square root of L. So now if I square both sides of the equation, squaring a square root just canceled it. So now we have L equal 1 over 2 pi frequency square root of capacitance. My math skills are suspect. I'm not sure if this is correct or not, so I put some bogus values in here and calculated frequency, and then I took that frequency and reran this equation and come up with L, or at least the value of L, which I used here, and it worked. So that should do the trick. So now we need to talk about the circuit. I have a diode video bombing us here. So I'm using my Feel Tech. If you're not familiar with the Feel Tech, Feel-Tech. Feel the quality of this Feel-Tech. So yeah, anyway, I have the Feel-Tech function generator, so I can adjust the frequency. That's why I put the arrow through it. And I have a parallel circuit here. It's called a tank circuit. Inductor and capacitance in parallel. Inductance and capacitance. Now I want to insulate, or I should say isolate, the Feel-Tech somewhat from the circuit, because this has impedance and some of the parasitics might interfere with the measurements. And when it's not in resonance, the impedance would be very low and be kind of like a short on the output of this. And because it's a Feel-Tech, you know, you gotta take some precautions. Anyway, so I'm using a 100 picofarad capacitor, and what I do now is connect the scope across the tank circuit and adjust the frequency until I get a peak. Now I know, since I'm using pretty low value components, you know, we're talking microhenries, 100 picofarads, this coil only has about 12 turns. It's actually 12.5 turns, so both ends can connect to the board. That extra half turn is electrically made up in the circuit, because circuit means circle, and electrically it would be made up, but the coil is wound with 12.5 turns. So this circuit is very sensitive to inductance and capacitance because of the low value. And the scope probe leads will have inductance and capacitance, but the main thing is the capacitance. You want to use 10x mode to minimize the capacitance. And even then, I don't have fancy pants probe leads, you know, $1,000 leads or anything, so there'll still be stray capacitance. What I think will happen is you'll probably measure the value of the inductor a little bit high, because stray inductance and capacitance might make this have longer time constants. You know, a larger inductance, larger capacitance, longer time constant. Okay, so I set the circuit up here on the breadboard. Yeah, I know breadboards aren't ideal, but I don't feel like soldering up everything just to test the coil. So I'll set my probe lead to 10x, it already is, and I'll just scope across the capacitor because it's an easy place to contact. So let me get you pointed at the scope, because I run out of hands for holding the camera and the scope probe lead here. And we'll take some measurements. I guess I should mention, if you have a device that'll measure inductance directly, you don't have to go through all of this. I do have a device that measures inductance, but just not low enough, so I have to check it with this. Alright, so we're looking at the scope, and see, as I adjust the frequency higher, it drops, and lower than the resonant point. So what I want to do is tune it in until I get the peak. So right there, and it looks like 14.1 megahertz. Okay, so I keyed all this stuff into the calculator over here, and it comes out 1.27 times 10 to the negative 6, and well, that's 1.27 microhenries. Now my handy Radio Shack book has this little chart in it. You just lay a straight edge across here. This was the frequency, 14.1. You know, 100 pico. That's the capacitance line. And here's the inductance. This is in microhenries. So that's 1.5, 1.4, 1.3. It's closer to the 1.2 line, though I probably could move it a little bit. Yeah, I got that lined up better now. 1.3. We were measuring 1.27, which close enough. Didn't even really need that formula, just used the chart. So there you go. Handy old Radio Shack data book. Okay, this is kind of why I ran that test. I'm using this online calculator. This one's from All About Circuits, which is a very nice website, by the way. So my coil radius is 0.5 centimeters, half a centimeter. The length, solenoid length, that's just the length of your coil, is 1.1 centimeters, 12.5 turns. And that's the permeability of air. You do not want to use ferrite or anything. You want it to be air core for the output of the amplifier. Relative permeability, I believe that would be 1 because it's an air, so it's not going to be different. It'd just be 1 because you see here relative permeability would just be 1 times the rest of the equation, so I don't see that as changing. But when I run the calculation here, it gives me 1.4 microhenries. And this other site here, what is it, 66pacific.com, it's just something I googled up. So I do the inductance calculation here, set it for centimeters, single layer coil. This equation here is the same as what's in the Radio Shack data book. I use that too. 2.5 turns. Now this is a diameter, it's not a radius, so it's 1 this time. The length is still 1.1 centimeters. And calculate. And this is what I expect, about 1 microhenry. So yeah, this is kind of why I ran the test on that coil. And I actually think the coil is closer to this than the measured value, because the measured value is going to have parasitics that's going to, raise the value somewhat. So I think the coil is actually what I want here, is around 1 microhenry. Here's yet another site. This is a neat site. It's got a whole bunch of translators. You can translate a fortnight of bushels into rototubulators if you wanted. But anyhow, they got a little single layer coil thing. And put my numbers in. And again, you get around 1 microhenry. In this case, they're slightly higher. The other one was like 0.99 something, and this one's slightly bit higher, so they're doing their math a little bit differently. So yeah, like I say, I seem to get around 1 microhenry when I use most of these calculators, except for that other one. Maybe I'm doing something wrong on that one, I don't know. Well, I have my Radio Shack electronic digital caliper here. Let's zero it out. It's zeroed, okay. And check the inside diameter. That could depend on where they're actually measuring. Are they measuring from the center of the conductors? I think that one site might have been, because in that case it's kind of hard to... Hang on a second here. I can't see through the viewfinder what I'm doing. Yeah, that's 11 millimeters. And the solenoid length, as they call it. Yeah, 11. And yeah, those little changes will affect your inductance quite a bit. But I'm just going to call it a 1 microhenry inductor, and that's what I've been using here. So yeah, we'll run with that. I think there's a Radio Shack open around here. It's in Eaton, Ohio, so it's quite a drive, probably a good 20-25 minutes. I have to go there and check and see if I can visit a actually operating Radio Shack. Wouldn't that be something? They're probably half smartphone sales now. I don't know what Radio Shack's doing, but I was forced into a smartphone. I'm with TracFone, who I think Verizon owns them now, and they're getting rid of the old 3G, so I was forced into a new phone. All the cheaper ones were sold, so I figured, yeah, I might as well try a phone like this. It's got a zillion cameras on it, little flashlight. I can throw away my cameras, my video recorders, and flashlight now. Just kidding, I'm not really going to do that, but what I'll try and do is film the rest of the video on this. I'm just kind of curious of what it's like. Before we get into that, let's wind a coil. Well, here's an earlier coil I wound years ago for something, but you can see it's kind of messy. It's not really nice like this is. So I want to have it on the board facing this direction so it's not parallel with these other devices, these resistors. Don't want to induce any stray currents. Now the silk screen on this board is going in the wrong direction, so I want to have it rotated. Don't have to move the holes or anything. That's one minor revision I want to do. Now you have to wind this in a certain direction. See how it starts here? No matter which way you're looking at it, it starts on the right side. Because if you started winding on this side, it wouldn't fit in this direction. It'd only fit in this direction. So I don't know if it matters that much, but I want it to face this direction. Now I'm using American wire gauge of 20. That's plenty adequate. And that would be 0.518 millimeters squared. So I found this wire here, enameled solid copper wire. And to wind it, you just find something. That's probably the hard part, is finding something as a coil former. And this is not the right size, but I'm just going to use this pin. I used a drill bit to wind this. I had one large enough. But anyhow, what you do is you just lay it on there and pin it down, and you pull it around here. Try to keep it parallel as you can, and kind of pull it. See, I'm not doing it very well to start off with. Now let me show you this diagram. Yeah, as you're winding it, kind of pull it over a little bit from, straight. That way, as you're winding it, it's pulling it over and keeping the gaps out of the coil. So let me put this back on. It's a good idea to tension the wire. Make sure your wire doesn't have kinks and stuff in it as well. And I would recommend not twisting the wire, but twisting the former that you're winding on. That way you don't develop any kinks in your wire. It'll put like a twisting tension on it. So you just, it's hard to do this on camera, but you can see we're forming a nice loop of wire like that. And you just wind it until you get the number of turns that you want. You have a nice looking coil in the end. Now the tedious part is getting the enamel off for soldering. And I just take a razor blade and scrape the enamel. I don't know about using a torch and burning it off. I'm afraid that would conduct and might damage the enamel up on the coil, but I just scrape it off. It's kind of tedious to do. If you have any other ideas, sandpaper or something, I don't know. But yeah, that's pretty much it. I make a nice looking coil. Okay, I think I got this going here. Hopefully I'm not covering up any microphones. wide angle mode. So yeah, this is the camera I normally use. Canon Vixia HF-R800. The camera before this was a little point and shoot, Canon point and shoot. I sent that to Radio TV Phono Nut back in October. His camera quit on him and he needed something. So I had an extra old camera sitting around I thought I'd help him out with. So that's, if you watch this channel, that's how that came to be. But anyhow, yeah. Got the camera in wide angle mode, or I guess as wide as it gets. Kind of move it around here, see what it's like. I don't know, I don't think I can zoom in while it's going. Apparently not on this one. But anyhow, a couple things before I close out. I'm working on another amplifier project, another idea, bringing the Easy Amp back to life. If you remember that one, kind of shelved it. This one would be called the Son of Easy Amp, so it'll be different. And we'll dump those Darlington output transistors. So look for that coming up. Another thing I want to do is collaborate on a power supply design for the 501 amp project. Yeah, I can do a power supply myself, but it's kind of fun to have collaboration on it. Eddie over at Kiss Analog channel, he's got a neat little channel there you might want to check out. He expressed interest in doing it. We'll look at your normal linear supply with the transformer, diode bridge, caps. Try to make a nice low ripple supply. And also a switch mode supply. And you might be saying, why a switch mode supply? Aren't those noisy and all that for audio amps? Well, if you think about it, that's how a lot of those car amplifiers work. They have a switch mode supply to give the dual rails for the power amp. A lot of those are pretty quiet, so why not? Last but not least is Patreon. Got some new supporters in. I really appreciate that. I'm not sure if they have it, but I need a way to put all of my files, my schematics, Gerber files, bill of materials, everything in one place. Now I just put them in a post and they scroll away. I'm thinking I will never put anything behind a paywall. It's available for everybody, whether you donate or not. You know, this is kind of a hobby for me, so, but I don't want to have to make it so you have to pay to get something. I want everything I do to be free. I got to figure that out so I can put all my files over there, make them available for you. Well, I guess that's it for this one. And you got to watch your fingers with these phone cams. And we'll wrap it up here. Thanks for watching.